Hello, in this lecture we will find the size of angle x in two different methods. In the drawing we have quadrilateral SRPQ, and we also know that side SP equals to side SQ, so we will define side SP as y, and then side SQ will be also equal to y, and we also know that angle PRQ, this angle is equal to 50 degrees, and angle SRP, this angle is equals to 65 degrees, and we want to find out angle PSQ, this angle that also equals to x. So we want to find out the size of angle x. So we will start with the first method. In the first method we will do a construction. We will extend side QR by a straight line, and then from point S we will raise perpendicular to the extended QR, so actually this angle equals to 90 degrees. It is a right angle, and we will define the touching point between the perpendicular to the extended QR as point N. Then in the next step we will draw perpendicular to PR. We will draw perpendicular to side PR, so this angle is a right angle, it equals to 90 degrees, and this angle is also a right angle, it equals to 90 degrees. So actually we extended side QR by a straight line. QR, it is a side of quadrilateral SRPQ, therefore it is a straight line, and we extended the straight line QR by a straight line, so QN will be also a straight line, and we have a rule number one. Rule number one states that the sum of the angles on one side of a straight line is equal to 180 degrees. I will write it down. The sum of the angles on one side on a straight line of the sum of the angles on one side of a straight line is equal to 180 degrees. So I will read rule number 1 again. Rule number 1 states that the sum of the angles on one side of a straight line is equal to 180 degrees. So, as I've already said, QN is a straight line. QN is a straight line. So, if we look on the straight line QN or NQ from this side, then we know that in this side the sum of the angles on the straight line QN at point R will be equal to 180 degrees according to rule number 1. So here we will define this angle as angle Z. So the sum of the angles from this side of the straight line NQ equals to 180 degrees. That is to say, the size of angle Z plus 65 degrees plus 50 degrees must be equal to 180 degrees according to rule number 1 that states that the sum of the angles on one side of a straight line equals to 180 degrees. So here we will subtract from this equality 50 degrees and we will get that Z plus 65 degrees equals to 180 degrees minus 50 degrees is 130 degrees. So we will subtract 65 degrees from this equality and we will get that the size of angle Z is actually 130 degrees minus 65 degrees is 65 degrees. So we found out that the size of angle Z is actually 65 degrees. Okay, so I can write here that angle SRN equals to 65 degrees. Okay, so in the next step, actually we draw perpendicular from point S to PR. So this angle is 90 degrees, this angle is 90 degrees, and we will define the touching point between the perpendicular to PR as point M. Okay, so in the next step we will prove that those two right triangles can go into each other. So we will prove that the green triangle SMR, right green triangle SMR is congruent to the blue right triangle SNR. Okay, we will prove that the green right triangle is congruent to the blue right triangle. Okay, so we will focus on triangles the green triangle, triangle SMR, and the blue triangle, triangle SNR. And we will prove that the green triangle is congruent to the right triangle. Okay, we focus on triangles SMR and triangle SNR. So, first of all, we have a common side. Side SR belongs to both triangles. It is a common side, so we write down that SR equals to SR. It is actually a common side. It belongs to both triangles, to the green triangle and also to the blue white triangle. So SR equals to SR. It's a common side. And those two angles are equal to each other and they are both equal to 65 degrees. So angle MRS, this angle in the green triangle, is equal to angle NRS in the blue triangle, and both angles are equal to 65 degrees. And we also have those two right angles. They are equal to each other. They are equal to 90 degrees. So angle SMR, this angle in the green triangle, is equal to angle SNR in the blue triangle, and they are both equal to 90 degrees. Okay, and we also know that the sum of the angles in any triangle equals to 180 degrees. Okay, so the sum of the angles in the green triangle will be equal to 90 degrees plus 65 degrees plus the size of the third angle. So we have here, if we focus on the green triangle, and it is also the same in the blue triangle because they have two equals angles. This angle is equal to this angle and this angle equals to this angle, so the size of the third angle in the green triangle will be also the same as the size of the third angle in the blue triangle. So the size of the sum of the angles in any triangle is equal to 180 degrees. So 90 degrees plus 65 degrees plus the size of this angle, we will define it as angle Z must be equal to 180 degrees. And actually this angle is also angle Z because of the fact that they have two equal angles. Okay, so here we have the equality that 90 degrees plus 65 degrees plus angle Z equals to 180 degrees. Here we will subtract 90 degrees from this equality, and we will get that 65 degrees plus angle Z equals to 180 degrees minus 90 degrees is 90 degrees. So here we will subtract 65 degrees from this equality, and we will get that the size of angle Z is actually 90 degrees minus 65 degrees is 25 degrees. So we found out that this angle equals to 25 degrees, and it is actually also the size of this angle in the blue triangle. It also will be equal to 25 degrees. So we actually also found out that angle MSR in the green triangle is equal to angle NSR in the blue triangle, and both angles are equal to 25 degrees. Okay, so actually we proved that the green triangle can go into the blue triangle, triangle SMR, the green triangle is congruent. This is the sign of congruent. Triangle SMR congruent to triangle SNR, the blue triangle. According to angle side angle rule. Okay, actually we proved more than we need to prove, because we actually proved that three angles, all the three angles of the green triangle can go into all the three angles of the blue triangle. So the angle side angle rule says that if two angles and the sides that attach to those two angles in one triangle are correspondingly equal to two angles and the sides that attach to those two angles in the other triangle, then you actually proved that the two triangles can go into each other according to angle side angle rule. So we actually have here two angles, and the side that attach to these two angles, that is to say SR, that correspond in the green triangle, that correspondingly are equal to two angles, and the sides that attach to those two angles, that is to say SR, in the blue triangle. Okay, so therefore those two triangles can go into each other according to angle side angle rule. And we actually proved that also we have the third angle that are equal in both triangles. So we actually proved more than what is needed to prove in order to prove that those two triangles can go into each other according to angle side angle rule. So from the fact that the green triangle is congruent to the blue triangle, we can conclude that side SM in the green triangle is equal to side SN in the blue triangle. SM equals to SN. SM is equal to SN according to the rule that corresponding sides in congruent triangles are equal to each other. The green triangle is congruent to the blue triangle, therefore those two corresponding sides will be equal to each other. Okay, so in the next step, that is to say Sm equals to Sn. So in the next step we will prove that those two right triangles can go into each other. Okay, so we will focus on the right triangle, triangle SMP, and on the right triangle, triangle SNQ. Triangle SNQ. Okay, so in the right triangle, triangle SMP, this right triangle, and triangle, the right triangle, triangle SNQ, this triangle. Okay, we will focus on those two right triangles, and we will prove that triangle SMP is congruent to triangle SNQ. Okay. First of all, we just right now proved that Sm equals to Sn. Sm equals to Sn. Sm in the right triangle SMP is equal to Sn in the right triangle SNQ. Sm equals to Sn. And we also know that Sp that equals to y equals to Sq that also equals to y according to what is given us in the question. So Sp equals to Sq and both sides are equal to y according to our definition. And we will prove now that Pm equals to NQ. Okay, we will prove that Pm in the right triangle SMP is equal to NQ in the right triangle SNQ. We will prove that Pm equals to NQ. You should remember that SMP and SNQ are right triangles, therefore we can implement the Pythagorean theorem in those two right triangles. We will actually can calculate the size of PM or MP according to the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So according to the Pythagorean theorem, if we focus on the right triangle, triangle SMP, SP square equals to SM square plus PM square. SP square equals to SM square plus PM square. Again, according to the Pythagoras theorem, in the right triangle, triangle SMP, SP square, that is the square of the hypotenuse, equals to SM square plus PM square. So here we will subtract SM square from this equality and we will get that PM square equals to SP square minus SM square. So here we will take a root out of this equality, and we will get that PM equals to the root of SP square minus SM square. So we took a root out of this equality, and we got that PM equals to the root of SP square minus SM square. Okay. And what is the value of NQ? We have here right triangle SNQ is a right triangle. Therefore, according to the Pythagoras theorem, SQ square will be equal to SN square plus NQ square. SQ square will be equal to SN square plus NQ square. Again, in the right triangle, triangle SNQ, according to the Pythagoras theorem, SQ square will be equal to SN square minus NQ square. Here we will subtract SN square from this equality, and we will get that NQ square equals to SQ square minus SN square. Okay, so here we'll take a root out of this equality and we will get that NQ equals to the root of SQ square minus SN square. Okay. Actually, those two expressions inside the root are equal to each other. I will show you why. We have here the expression that PM equals to SP square minus SM square. Actually, this expression is equal to this expression that equals to NQ. Equals to the root of SQ square minus SN square. Those two expressions are equal to each other. Why? Because SP is equal to SQ. SP is equal to SQ. So you can see from the drawing, SP is equal to SQ. It is given us the equation that SP equals to SQ, and they are both equal to Y. SP equals to SQ equals to Y. And actually, SM is also equals to SN. SM equals to SN. SM equals to SN. According to what we have already proved, SM equals to SN. Okay, so those two expressions are equal to each other. Okay, therefore PM equals to NQ. Okay, this is PM that equals to this expression that equals to NQ. So PM equals to NQ. So we actually proved that all the three sides of the right triangle SMP are equal to, correspondingly, are equal to all the three sides of the right triangle SNQ. Therefore, we actually proved that the right triangle SMP is congruent. The right triangle SMP is congruent to the right triangle SNQ according to side rule. So what is side rule? Side rule states that if you prove that all the sides of one triangle are correspondingly equal to all the sides of another triangle, then you prove that those two triangles can go into each other according to side rule. So from the fact that those two right triangles can go into each other, we can conclude that those two angles are equal to each other. Again, angle SQN is equal to angle SPM angle SQN is equal to angle SPM according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore those two corresponding angles will be also equal to each other. Again, those two triangles congruent to each other, therefore those two corresponding angles will be equal to each other. And if this angle is equal to theta according to our definition, then this angle will be also equal to theta because of the fact that those two angles are equal to each other. So we found out that angle SQN equals to angle SPM equals to theta. So in the next step, I will present to you a new rule, rule number 2. Rule number 2 states that if a segment line subtends two equal angles on the same side, then the quadrilateral is inscribed by a circle, and the 4 points lie on that circle. So I will read rule number 2 again. Rule number 2 says that if a segment line subtends 2 equal angles on the same side, then the quadrilateral is inscribed by a circle and the 4 points lie on that circle. Okay, so here we have 2 equal angles, they are both equal to theta, that subtends on the same line segment SR. Again, those 2 equal angles, they are both equal to theta, subtend on the same segment line SR from the same side. Therefore, according to rule number 1, or according to rule number 2, this rule, the quadrilateral SRPQ is inscribed by a circle, and the 4 points S, R, P, and Q lie on that circle. Okay, so according to rule number 1, actually here we have those 2 equal angles that they are both equal to theta. They subtend on the same segment line SR. Therefore, according to rule number 2, this quadrilateral SRPQ is inscribed by a circle, is inscribed by this circle, and the 4 points S, R, P, and Q lie on that circle. Okay, as you can see, those 4 points S, R, P, and Q lie on this blue circle. Okay, so this is actually the implementation of rule number 1 in our drawing. Okay, and we have also rule number 2. Rule number 2 states that peripheral angles that subtend on the same chord are equal to each other. Peripheral angles that subtend on the same chord are equal to each other. So I read rule number 2 again. Rule number 2 states that peripheral angles that subtend on the same chord are equal to each other. Again, we can implement rule number 2 in our drawing. Here we have 2 peripheral angles. Angle PSQ that equals to X is a peripheral angle that subtend on chord PQ, And we have also angle PRQ that equals to 50 degrees that subtend on the same chord PQ. Therefore, according to rule number 2, those two peripheral angles that subtend on the same chord are equal to each other. That is to say, x equals to 50 degrees. So actually we found out that x equals to 50 degrees according to rule number 2. I will explain again. Those two peripheral angles x and PRQ that equals to 50 degrees subtend on the same chord PQ. Therefore, they are equal to each other according to rule number 2. That is to say, x equals to 50 degrees. So we found out that x equals to 50 degrees according to rule number 2, and we finished with the first method. So we will, in the next step, we will find out the size of angle x according to the second method. In the second method, we will do another construction. Actually, we will extend the side SR of quadrilateral SRPQ after we extended side SR by a straight line. We will raise perpendicular from point Q to the extended SR. So this is a right angle. It equals to 90 degrees according to our construction, and we will define the touching point between the perpendicular to the extended SR as point M, and in the next step we will extend the perpendicular QM in such a way that Q dash M will be equal to QM. Again, Q dash M, this Q dash M will be equal to QM according to our construction. We will extend QM in such a way that Q dash M will be equal to QM. And then we join together points R and Q dash by a straight line. And we will join together points Q dash and S by a straight line. again Q dash M equals to QM according to our construction. So here SR is one side of the quadrilateral SRPQ, therefore it must be a straight line, and after we extended the straight line SR by a straight line, we still will receive a straight line, so SM will be also a straight line. And we know that the sum of the angles on one side of a straight line according to rule number 1 that I mentioned in the first method is equal to 180 degrees. So I'll write it down. So we actually know that SM is a straight line, and we have rule number 1 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the bottom side of the straight line SM at point R, the sum of the angles must be equal to 180 degrees. So here we will define this angle as angle Z, and we know that in the bottom side of the straight line SM at point R, the sum of the angles must be equal to 180 degrees according to rule number 1. That is to say 65 degrees plus 50 degrees plus the size of angle Z must be equal to 180 degrees according to rule number 1. Okay, 65 degrees plus 50 degrees plus the size of angle Z must be equal to 180 degrees according to rule number 1. So here we will subtract 50 degrees from this equality, and we will get that 65 degrees plus angle Z equals to 180 degrees minus 50 degrees is 130 degrees. Here we will subtract 65 degrees from this equality, and we will get that Z equals to 130 degrees minus 65 degrees is 65 degrees. So we found out that the size of angle Z is actually 65 degrees. So we can write here that angle actually QRM is equal to 65 degrees. Okay. Actually here we raise perpendicular from point Q to M. So this is a right angle, it equals to 90 degrees. And we'll find out the size of this angle. We'll define it as angle L. Actually, QM is perpendicular to the extended SR. QM is perpendicular to SM. So QM as perpendicular must be a straight line. And we extended this straight line QM by a straight line. Therefore, QQ dash must be also a straight line because we extended the straight line QM by a straight line. So QQ dash is a straight line. Line segment QQ dash is a straight line. Line segment QQ dash is a straight line. And we have rule number 1 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. That is to say, if we focus on point M on this side of the straight line QQ dash, the sum of the angles must be equal to 180 degrees. So which angles we have on this side of the straight line QS, we have here 90 degrees plus L. So according to rule number 1, 90 degrees plus angle L must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line must be equal to 180 degrees. So here we will subtract 90 degrees from this equality and we will get that L equals to 180 degrees minus 90 degrees is actually 90 degrees. So we found out that the size of angle L is equal to 90 degrees. Angle L is a right angle, so this angle is a right angle. So in the next step we will focus on these two right triangles and we will actually prove that those two right triangles can go into each other. So we will focus on the right triangle, this right triangle, triangle QMR. And the right triangle, triangle QDES-MR. And we will prove actually that those two right triangles can go into each other. We will prove that the right triangle QMR can go into the right triangle QDES-MR. First of all, we know that QM equals to QDES-M. QM equals to QDES-M according to our construction. So we can write down that QM equals to QDES-M according to our construction. We also know that those two angles are equal to each other. They're both equal to 90 degrees. So angle QMR in triangle QMR is equal to angle QDES-MR in triangle QDES-MR, and both angles are equal to 90 degrees. Angle QMR equals to angle QDES-MR and both angles are equal to 90 degrees. And we also have here a common side. That is to say, RM is a common side. It belongs to both triangles. So we can write down that RM equals to RM as a common side. That belongs to both triangles. RM equals to RM. So we actually proved that the right triangle QMR is congruent to the right triangle QDES-MR according to side angle side rule. So I write it down. Triangle QMR is congruent. Again, this is the sign of congruent. The right triangle QMR is congruent to the right triangle QDES-MR according to side angle side rule. So what is side angle side rule? We actually proved that those two sides and the angle between them in triangle QDES-MR are correspondingly equal to those two sides and the angle between them in the right triangle QMR. Therefore we proved that those two triangles can go into each other according to side angle side rule. So from the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other. according to the rule that corresponding angles in congruent triangles are equal to each other. But we know that this angle equals to 65 degrees, therefore this angle must be also equal to 65 degrees because of the fact that those two angles are equal to each other. So we can write down that angle QRM is equal to angle Q dash RM, and both angles are equal to 65 degrees. Okay, angle QRM is equal to angle Q dash RM, and both angles are equal to 65 degrees. We also can conclude that those two sides are also equal to each other according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other. Therefore, those two corresponding sides will be also equal to each other. That is to say, RQ, side RQ of triangle MQR is equal to side RQ dash of triangle MRQ dash of triangle MRQ dash. Okay, again, RQ equals to RQ dash according to the rule that corresponding sides in congruent triangles are equal to each other. Okay, again, we know that SP equals to SQ. SP is equal to SQ, so if we define SP as Y, then SQ will be also equal to Y because of the fact that they are equal to each other. Okay, so in the next step we will focus on the right big triangle QMS, this right big triangle, and we will also focus on the right big triangle QDS this big right triangle. And we will actually prove that those two big right triangles can go into each other. Okay? Again, we will focus on the right big triangle QMS, and the right big triangle QDS, this big right triangle. We will actually prove that those two right big triangles can go into each other. Okay, those two right big triangles can go into each other. First of all, we know that QM equals to Q dash M according to our construction. QM is equal to Q dash M according to our construction. Okay? QM equals to Q dash M according to our construction. I will write here, it is our construction. We also know that those two angles are equal to each other, they're both equal to 90 degrees. So angle QMS of triangle QMS is equal to angle Q dash MS, and both angles are equal to 90 degrees. Angle QMS is equal to angle Q dash MS, and both angles are equal to 90 degrees. And we also have here a common side. SM is a common side because it belongs to both triangles. So we can write down that SM equals to SM as a common side. SM equals to SM as a common side. So again SM equals to SM as a common side. So we actually proved that the right big triangle QMS is congruent to the right big triangle Q dash MS according to side angle side rule. So I write it down. Triangle QMS, the right big triangle QMS, is congruent to the right big triangle Q dash MS according to side angle side rule. According to side angle side rule. I've already mentioned I explained what is side angle side rule. We actually proved that those two sides and the angle between them on the right triangle Q dash MS are corresponding equal to those two sides and the angle between them of triangle QMS. Therefore, we proved that those two right big triangles can go into each other according to side angle side rule. So, from the fact that those two triangles can go into each other, we can conclude that QS equals to Q dash S according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other. Therefore, those two corresponding sides will be equal to each other. So we can write down that QS equals to Q dash S. QS equals to Q dash S. QS equals to Q dash S. But we know that QS equals to Y. Therefore, Q dash S will be also equal to Y because of the fact that they are equal to each other. So Q dash S also equal to Y. So we found out that QS equals to Q dash S and they are both equal to Y. Okay. So in the next step, we will focus on triangles SRQ and triangle SRQ dash. This triangle SRQ dash. And we will actually prove that triangle SRQ is congruent to triangle SRQ dash. Okay? First of all, we have already proved that RQ equals to RQ dash. We have already proved that RQ equal to RQ dash. Okay? We already proved that RQ equals to RQ dash. And we also know that SQ equals to SQ dash, and both sides are equal to Y. SQ equals to SQ dash, and both sides are equal to Y according to our definition. SQ equals to SQ dash, and they are both equal to Y. And we also have here a common side. SR belongs to both triangles, so we can write down that SR equals to SR as a common side. It belongs to both triangles. Okay, SR equals to SR as a common side. So we actually proved that all the sides of triangle SRQ are equal to all corresponding equal to all the sides of triangle SRQ. Therefore, we proved that triangle SRQ is congruent to triangle SRQ according to side rule. Triangle SRQ congruent to triangle SRQ dash according to side rule. Actually, side rule states that if you prove that all the sides of one triangle are corresponding equal to all the sides of the other triangle, then you prove that those two triangles can go into each other according to side rule. And we prove that all the sides of triangle SRQ are equal to all the sides of triangle SRQ. Therefore, we prove that those two triangles can go into each other according to side rule. So from the fact that those two triangles can go into each other, we will conclude that those two angles are equal to each other according to the rule that states that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding angles will be also equal to each other. Okay, so we can write down that angle SQR is equal to angle SQ dash R. Angle SQR equal to angle SQ dash R according to the rule that corresponding angles in congruent triangles are equal to each other. And if we define angle SQR as theta, then angle SQ dash R will be also equal to theta because of the fact that those two angles are equal to each other. So we found out that angle SQR is equal to angle SQ dash R, and both angles are equal to theta. Okay, so in the next step we will prove that line segment PQ dash, this line segment PQ dash is a straight line. Okay, we will prove that PQ dash is a straight line. We will prove it by proving that angle PRQ is angle that equals to 180 degrees. So if we look from the bottom side of angle PRQ, we will calculate the size of angle PRQ from the bottom side. So the size of angle PRQ is actually 50 degrees plus 65 degrees plus 65 degrees. So in total, 65 degrees plus 65 degrees is 130 degrees, and 130 degrees plus 50 degrees is 180 degrees. So we proved that angle PRQ is angle that equals to 180 degrees. Actually, any angle that equals to 180 degrees must be a straight line. Therefore, actually, the line segment PRQ dash, it is actually PRQ dash. The line segment PRQ dash is a straight line. Because of the fact that it is angle that equals to 180 degrees, it is a straight line. So if PRQ dash is a straight line, then PQ dash must be also a straight line. PQ dash is also a straight line. So PQ dash is a straight line because of the fact that PRQ dash is a straight line, and because of the fact that PQ dash is a straight line, then the shape SPQ dash is a triangle. SPQ dash is a triangle. From the fact that PQ dash is a straight line, we will conclude that SPQ dash is a triangle. So if you focus on triangle SPQ dash, in this triangle SPQ dash, we know that side SP equals to side SQ dash, and they are both equal to Y according to our definition. So SP equals to, or SP equals to SQ dash, and both sides are equal to Y according to our definition. And we actually have the rule that states that in front of equal sides in the triangle there are equal angles. So here in front of this side SQ we have this angle, and in front of this side SP we have this angle. So this angles are equal to each other according to the rule that in front of equal sides there are equal angles. Those two angles are equal to each other, but we know that this angle equals to theta, so this angle must be also equal to theta because of the fact that they are equal to each other. So we found out that this angle equal to theta. Okay, so from this point we'll continue according to method 1. So here we have two angles that are equal to each other. They are both equal to theta, and those two angles that are equal to each other subtend on the same segment line, that is to say SR. This angle theta subtend on line segment SR, and this angle theta subtend on the same segment line SR. Therefore, according to rule number 1 that I mentioned, according to rule number 2 that I mentioned in method 1, the quadrilateral SRPQ, this quadrilateral is inscribed by a circle, and the 4 points SRPQ lie on that circle. That is what we did in method 1. Again, we have those two equal angles, they are both equal to theta, that subtend on the same segment line SR. Therefore, according to rule number 2, the quadrilateral SRPQ, this quadrilateral is inscribed by a circle, and the 4 points S, R, P, and Q lie on that circle. As you can see, those 4 points S, R, P, Q lie on this blue circle. Okay, this is the implementation of rule number 2 in our drawing. And we have also rule number 3 that states that peripheral angles that subtend on the same chord are equal to each other. And we have those two peripheral angles. Peripheral angle PSQ that equals to X subtend on chord PQ, and peripheral angle PRQ that equals to 50 degrees subtend on the same chord PQ. Therefore, according to rule number 3, they are equal to each other. That is to say, X equals to 50 degrees. So actually, X equals to 50 degrees according to rule number 3. Again, rule number 3 states that peripheral angles that subtend on the same chord are equal to each other. Those two peripheral angles subtend on the same chord PQ, therefore they are equal to each other. That is to say, X equals to 50 degrees. Okay? So we finished with method 2. Now I will summarize the lecture. Actually, we wanted to find out the side of angle X that is also equals to PSQ. And in the first method, we made a construction we actually extend that side QR by a straight line, and then from point A we draw perpendicular to the extended QR, so this angle is 90 degrees, and then we drew another perpendicular from point S to PR. The touching point between the perpendicular to PR is point M, so this angle is 90 degrees and this angle is also 90 degrees. And here the touching point between the perpendicular to the extended QR is point N. Then we actually calculated the size of this angle. Actually, QR is one side of quadrilateral SRPQ, therefore it must be a straight line. Then we extended the straight line QR by a straight line, so it remains a straight line. So QN remains a straight line, and we have rule number 1 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we look on the bottom side of the straight line QN at point R, the sum of the angles must be equal to 180 degrees. That is to say 50 degrees plus 65 degrees plus the size of this angle that is defined as angle Z must be equal to 180 degrees. Okay? Then we subtracted 50 degrees from this equality and we got that Z plus 65 degrees equals to 130 degrees. Then we subtracted 65 degrees from this equality and we got that angle Z equals to 65 degrees. So we found out that this angle Z equals to 65 degrees. Okay? Then we actually proved that the green right triangle is congruent to the blue right triangle. Why? Because we have SR that is a common side, it belongs to both triangles, so SR equals to SR as a common side. We also have those two angles that they are both equal to each other, they are both equal to 65 degrees. And we have also those two angles that are right angles, they are equal to 90 degrees. Okay, so we have the common side SR equals to SR, those two angles are equal to 65 degrees, and those two angles are equal to 90 degrees. And because of the fact that we have two angles, that one angle is equal to 65 degrees and the other angle is equal to 90 degrees, so in total the sum of those two angles is 155 degrees. And we have the rule that states that the sum of the angles in any triangle is 180 degrees. So the size of the third angle must be equal to 180 degrees minus the sum of those two angles, that is actually 155 degrees. That is to say, the size of the third angle must be equal to 25 degrees, because 180 degrees minus 155 degrees is 25 degrees. So the size of these two angles are both 25 degrees, they are equal to each other. So we actually proved that all the angles in the green triangle are corresponding equal to all the angles of the blue triangle. And we have also the common side SR. So we actually proved that the green triangle is congruent to the blue triangle according to side angle rule. If you have two angles and the side that attach to those two angles in one triangle that are correspondingly equal to two angles and the side that attach to those two angles in the other triangle, then you proved that those two triangles can go into each other according to side angle rule. Okay? So we proved that those two triangles can go into each other according to side angle rule. From the fact that those two triangles can go into each other, we can conclude that SM equals to SN according to the rule that corresponding angles in congruent triangles are equal to each other. So SM equals to SN. SM equals to SN. Then we focused on the right triangle, triangle SMP, and on the right triangle, triangle SNQ, and we proved that those two right triangles can go into each other. First of all, we just right now proved that SM equals to SN. Then we know that SP equals to SQ, and both sides are equal to Y. It is given us in the equation that they are equal to each other. And then we proved that PM equals to NQ. PM equals to NQ according to the Pythagorean theorem. We know that the square of the hypotenuse equals to the sum of the squares of the perpendiculars in a right triangle. So here in the right triangle SMP, we know that SP square equals to SM square plus PM square. Okay, according to the Pythagoras theorem, in the right triangle SMP, SP square equals to SM square plus PM square. Here we subtracted SM square from this equality and we got that PM square equals to SP square minus SM square. Here we took out a root out of this equality. We took a root out of this equality and we got that PM equals to the root of SP square minus SM square. Then we focused on the right triangle, triangle SNQ. On the right triangle, triangle SNQ, according to the Pythagoras theorem, SN square plus NQ square will be equal to SQ square. Okay, SQ square equals to SN square plus NQ square. Then we subtracted SN square from this equality and we got that NQ square equals to SQ square minus SN square. Then we took a root out of this equality and we got that NQ equals to SQ square minus SN square. So actually these two expressions are equal to each other. We wrote these two expressions together. They are actually equal to each other. Why? Because SP equals to SQ. It is given us in the question, and we have already proved that SM equals to SN. Here, SM equals to SN. We have already proved it. So actually those two expressions are equal to each other. So this expression is PM is equal to this expression that is NQ. So we proved that PM equals to NQ, and therefore we actually proved that all three sides of triangle SMP are corresponding equal to all the three sides of triangle SNQ. Therefore, we actually proved that triangle SMP is congruent to triangle SNQ according to side rule. From the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other. According to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding angles will be equal to each other. And if this angle is defined as theta, then this angle will be also equal to theta because of the fact that they are equal to each other. Okay, then I presented to you rule number 2. Rule number 2 states that if two segment lines subtend two equal angles on the same side, then the quadrilateral is inscribed by a circle and the 4 points lie on that circle. So we can implement rule number 2 in our drawing, because in our drawing we have two equal angles. Both those two angles are equal to theta that subtend on the same segment line SR. Therefore, according to rule number 2, the quadrilateral SRPQ is inscribed by a circle and the 4 points S, R, P, and Q lie on that circle. Okay, according to rule number 2, because of the fact that those two angles that are equal both to theta subtend on the same segment line SR, therefore, according to rule number 2, the quadrilateral SRPQ is inscribed by a circle, and those two 4 points S, R, P, and Q lie on this circle. This is according to rule number 2, and we also have rule number 3 that states that peripheral angles that subtend on the same chord are equal to each other. Peripheral angles that subtend on the same chord are equal to each other. So those two peripheral angles, peripheral angle X and peripheral angle PRQ, that equals to 15 degrees, both of them subtend on the same chord PQ. Therefore, according to rule number 3, they are equal to each other. That is to say, X equals to 50 degrees. Okay, so we finished with method 1. Then we found out the size of angle X according to the second method. In the second method, we actually extended side SR, and then from point Q we draw perpendicular to the extended SR, so this angle is 90 degrees. Then we actually extended the perpendicular QM in such a way that Q dash M equals to QM. Okay, and then we actually calculated the size of this angle. We actually know that SR is one side of quadrilateral SRPQ, therefore it must be a straight line. Then we extended the straight line SR by a straight line, so SM must be also a straight line. So if we focus on the bottom side of the straight line SM, the sum of the angles must be equal to 180 degrees according to rule number 1. So here we have 65 degrees and 50 degrees. Therefore this angle must be equal to 65 degrees in order to complete the sum of the angles in the straight line SM at point out to 180 degrees. And here we actually have QM is perpendicular to the extended SR, therefore it must be a straight line, and then we extended the straight line QM by a straight line. So QQ dash must be a straight line, and the sum of the angles on this side of the straight line QQ dash at point M must be equal to 180 degrees. That is to say 90 degrees plus the size of this angle must be equal to 180 degrees. Therefore this angle must be equal to 90 degrees in order to complete the sum of the angles at point M on this side of the straight line QQ dash to 180 degrees. So this angle is also 90 degrees. Then we actually proved that those two triangles congruent to each other, and therefore, because of the fact that those two triangles congruent to each other, we can conclude that those two angles are equal to each other. So if this angle is 65 degrees, this angle must be also equal to 65 degrees, and those two sides, side QR, must be equal to side RQ according to the rule that corresponding sides and congruent triangles are equal to each other. Then we proved that the big triangle QMS are equal to the big right triangle Q dash MS, and from that fact we actually we concluded from the fact that those two big triangles congruent to each other that SQ equals to SQ dash. So, and SQ equals to y, therefore SQ dash must be also equal to y because of the fact that they are equal to each other. Then we proved that those two triangles can go into each other according to side rule, and from that fact that they can go into each other, we concluded that those two angles are equal to each other. Then we proved that PQ dash is a straight line, therefore SPQ dash is a triangle, and in triangle SPQ dash we have two sides that are equal to each other, therefore we have the rule that states that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front, the equal sides, must be equal to each other, and we know that this angle equals to theta, so this angle must be also equal to theta because of the fact that those two angles are equal to each other. Then we have here two angles that are equal to each other and then subtend on the same chord, on the same line segment SR. So according to rule number 1, because of the fact that they subtend on the same line segment SR, we can conclude from it that the quadrilateral SRPQ is inscribed by a circle, and the 4 points SR, P, and Q lie on that circle. Okay? And we have rule number 2 that states that peripheral angles that subtend on the same chord are equal to each other. So we have here two peripheral angles, angle X and angle PRQ, that equals to 50 degrees. They subtend on the same chord PQ, therefore they are equal to each other. Therefore they are equal to each other according to rule number 3, that is to say X equals to 50 degrees. Again, X equals to 50 degrees because of the fact that those two peripheral angles subtend on the same chord PQ, therefore X equals to 50 degrees. Okay, thank you very much.